Okay, so this is homework number 6, converting to vertex form. There was a computer printing issue that I didn't feel like dealing with, so I'm just going to write it on plain paper here. I'm going to do 2 examples, one from the front. So starting with number 2, we have a 5-step process to converting into vertex form. So I just wanted to write the vertex form right here, just so we had it right in front of us and we know what our end goal is. So step number 1, we want to group ax squared plus bx. Okay, so we're kind of taking just this first part right here, just grouping those 2 items together. Okay, so for now, it's almost like we're ignoring that -1 at the end. So that's step 1, very easy step. Step number 2, if a isn't 1, factor it outside. Okay, so here a is 1. A, remember, is the number in front of the x squared. So 2 for right now is a step that we can skip. So skip over number 2. Don't worry about factoring a number right here out because it's just a 1. Number 3, complete the square by taking half of b and squaring it. Okay, so we take whatever this little number is right here. So for us, it's a 4. We're going to cut that number in half, which gives us 2. And then you take that 2 and you square it. Okay, so this one, it's actually a complete coincidence that you end right back up at 4. This is the only number where you cut it in half and square it and you end up back with the same number. Okay, so we take that value. This is the new c. Okay, so we're going to add this to x squared plus bx, and that becomes the perfect square trinomial. So back to our little set of parentheses here. So we're still going to work within the set of parentheses. So we have x squared plus 4x plus 4. So that's what we just added. Okay, so for right now, I'm finishing up step 3 just by adding that new value. Step 4 is to subtract a times c from the end of the equation. Okay, subtract a times c from the end of the equation. So a is technically a 1, times c is 4, and I'm going to subtract that from the end of the equation. So that's my second to last step. Step 5, factor the trinomial, simplify the end of the equation. Okay, so f of x equals, we are going to take this guy right here and factor it down. Okay, so the number that multiplies to 4 and adds to 4 is a positive 2. So I write it as x plus 2 squared because it would be a perfect repeat. Remember, we reviewed those perfect square trinomials that always end up in this form. And then simplify the end of the equation. So -1 minus 4 is -5. So this is our answer for the actual equation itself. Directions also asked you to identify the vertex. And the vertex is pretty easy once it's in this form. Remember, the x-coordinate is the opposite of the number that you have in parentheses here. So that would be a -2. And then the y-coordinate is the exact number that you see on the end here. Keeping in mind that one or both of those numbers could potentially end up being a 0. All right, so that was the first type where you just get it into vertex form and then we're identifying just what the vertex is. The second type, we're gonna start to graph. So convert it to vertex form first. We wanna talk vertex, axis of symmetry, and then we're gonna end up graphing it. Okay, so this one, we're gonna follow the same 5-step process to get this into vertex form. So step 1, group the ax squared plus bx. So we're gonna group just those 2 together and kind of focus on that for right now. Step 2, we actually are going to have to do this time. If a isn't 1, which it isn't, a is a -2, factor it outside, just from this group right here. Nothing to do with this -1. So we're going to factor that -2 outside. So this becomes just an x squared. When I factor a -2 out of the 8x, I end up with a -4x. Okay, so that was step 2. There was an a that wasn't 1, so we factored it out. Step 3, complete the square by taking half of b and squaring it. So we're taking this middle number right here. So we're going to take half of that middle number, which ends up being a -2. And then we're going to take that -2 and square it. And that comes back as a +4. This number that we get in step 3 should always be positive because no matter what you cut in half, when you square it, it comes back as being positive, even if it's a negative number like we had here. So part of step 3, we're going to add this to what we have inside the parentheses, and that becomes the perfect square trinomial. So rewrite this again. So we're going to add that number that we just came up with inside the parentheses. Okay, so that was this value that we just added right here. That's step 3. Step 4, subtract a times c from the end of the equation. Okay, subtract a times c from the end of the equation. So a times c, negative 2 times positive 4 is negative 8, and we are going to subtract a negative 8 from the end of the equation. One last step, factor the trinomial, simplify the end of the equation. So factor this down. The number that multiplies to positive 4 and adds to negative 4 would be negative 2 and negative 2. So I repeat that factor and then simplify the end of the equation. And that is what I get. So first thing I was trying to do was actually to get that equation. I also need to identify the vertex and the axis of symmetry. So the vertex is just like I did with number 2. You take the opposite of this number for the x-coordinate and then this exact number for the y-coordinate. So positive 2 for the x-coordinate, positive 7 for the y-coordinate. And then the axis of symmetry is just x equals the same value that you had right there for that x value. Okay, so we got those 3 things that I asked you to identify. We're going to set up a table, and then we're going to graph. All right, so our f of x table. Remember, you start by centering whatever this value is, and then you go down and up. Okay, so we know that this is our center value here. The rest of them we can plug in, and once we plug them in, we know that that symmetry is going to be there. So we'll be able to just repeat the bottom half of the table based on the top half. All right, so let's take this first value. So plugging in right here to this equation. So I have a negative 2, and then in parentheses, negative 1 minus 2 squared plus 7. So this comes out to be a negative 11, which I can then repeat at the end of my table here. Do the same thing with 0. So negative 2 in parentheses 0 minus 2 squared plus 7. That comes out to be negative 1, which I repeat here. And then one more symmetric value. I can plug in this 1. Or you could go from the bottom and then repeat those. Either way, you've got the symmetry. 1 minus 2 squared plus 7. Okay, so that comes out to be 5. And this comes out to be 5. So you've got all those values, and we just plot them, connect the dots, and we've got our graph. Okay, so negative 1, negative 11. That's going to go off your graph. But I'm making my own. So there we go. 0, negative 1. 1, 5. Of course, mine's not going to be quite as pretty because I'm making my own grids. 2, 7, and then it repeats itself back down the other side. Okay, so just connect the dots. Again, yours will look much prettier because you have a perfectly spaced grid, but this is what your equation should look like.